What is up? It's your boy the Canologist. We're going to be doing the question integer to Roman. And as you guys know, these are Roman numerals on the left. I don't know about C, D, and M, but I know like I, V, X, because maybe the clock only goes up to there. It doesn't go up to like 50 or 100 and 500 and 1,000. Oh my gosh. Okay. So let's look at this. 7 different values, 7 different symbols. This is a medium question. 7 different symbols represent Roman numerals. Okay, so we got I, VX, CLD. Okay. Roman numerals are formed by appending the conversions of decimal place values from highest to lowest. Okay. Converting a decimal place value into a Roman numeral has the following rules. Okay, so give us some rules here. If the value does not start with 4 or 9, select the symbol of the maximum value that can be subtracted from the input and append that symbol to the result, subtract its value, and convert the remainder to a Roman numeral. If the value starts with a 4 or 9, use the subtractive form representing the one symbol subtracted from the following symbol. 4 is 1, less than 5, add IV, is 1 less than 10. Only the following subtractive forms are used. Only the following subtractive forms are used. 4 is IV, 9 is IX, 40 XL, XL, 90 XC, XL, XC. X is 10, L, okay, XC, okay, that makes sense. 400 is CD, 500 is CM. Only powers of 10 can be appended consecutively at most 3 times. Fuck. Okay, so I, X, C, and M can be appended consecutively at most 3 times. You cannot append 5 V's, 50L, or 500D. So you cannot append 550 or 500 multiple times. You need to append a symbol of 4 times use subtractive form. I'm already getting a headache from this shit. Okay. So, what do they have here? They have an input number. It's 3,749. So 3,740 and 9. Number 2, 50 and 8. 1,900 and 90 and 4. So I guess the way to do it is to break down the number and append it to a string. So Yeah, Roman numerals are just a big appendage of these numerals. So like 3000 would be MMM. So I'm thinking I have to create some sort of dictionary first to store all this. So let's go. Okay, it's between 1 and 4000. And then I want to create a string output for, so output equals string. So I have to create first this value of tables here. So I equals 1. One equals I. So these are all the given values. So if I ever find these, then I want to use them. Thousand is M. Okay, now let's go to the other rules. If the value does not start with a 4 or 9, select the symbol of the maximum value that can be subtracted from the input and append that symbol to the result. Subtract its value and convert the remainder to a Roman numeral. So if it's like 4, so like if we go to 1994, we append 5. Value does not start. Select the maximum value that could be subtracted from the input. So 4 convert the remainder to a Roman numeral. Okay. How do I get to 3,000? I'm thinking of that. I'm just like thinking how I could get rid of it. Oh, one sec. I gotta put my laundry away. One second. Okay, I'm back. Put my laundry away. Okay, let's see. So I got all this. Let's add the values for 4, 9, 1. Four is 1 less than 5. 9 is 1 less than 10. Let's see. X is 40, so 40 is 1 less than 50. $90 is 1 less than, this is I guess 10 less than 100. $400 is 100 less than 500. $900 is 100 less than 1,000. Only powers of 10 could be consecutively added. Subtractive form. Okay, so now I have to figure out how to separate this. So how to separate, so let's just check it. How to separate into number into parts for thousands, hundreds, tens, ones. How to say numbers with, okay, so modulus. You could divide modulus 10. Modulus 10 will get you the last digit of every integer. Divide by 10 removes the last digit. Repeating these operations can accomplish your goal. So let's say 5, 8, 9, 7. So if you do modulus 10, it basically cuts off the last element. And then modulus 10 gets you the last digit. Modulus 10 removes the last digit. So modulus 10, so this is the remainder, divided by 10, gives you the last digit, so 7. And then divided by 10, gives you 5, 8, 9. So this is how I want to go about it. You have to do it backwards, basically. You have to go and then you have to figure out how to get each one. So first we want to get 587, right? 589, 589, right? And then you want to go 589 modulus 10 gives you 9, 90. Or actually, it would be 9. And then you have to times it by whatever the place is, so times 10. 7 times 1. And then it would be 8. So when you divide by 10, you get 58. Right? And then it would be 8 times 100. Right? And then 5 times 1,000. Right? So you have to go through each one until you get to the last one. The only thing is, how would you go about it here? I'm already at 21 minutes. I'm going to give it 9 minutes till I figure out how to do this. Because I'm just going to chat GPT it. I'm not going to lie. It's a long answer. So, for example, 58. Let's do that. So 58. I want to go. I can create a stores. To hold the elements. So I could go 58. So for example, I could go num modulus 10 I guess I don't know how to go whether it would be greater than or less than. That's the only thing. So like for example, if I get to 5, then what? Do I just go modulus? Well, the digit will now equal 0. Because 5 divided by 10 is 0. And remainder 5. And then times 1,000. That's what it would be. So while num is greater than 0, and then I could go we convert the remainder to a Roman. Okay. I think it's actually easier if you just put 1 to 10 on here and just convert it. So for example, 1, 2, 3, because the rest is can be digits and then multiples of 10 and 100 and 1,000 possibly. 4 is already there. 5 is already there. And then 9 is already there. And then 8 is V. And then all you have to do now is just figure out what the number is and then append whatever to it. So while num is greater than 0, first I want to let's call this mult equals 1. That's my multiplier. This tracks the place that it's in. And then I want to look at so first I want to get the digit. Digit equals num percent 10. So I get the final digit. Num percent 10, and I'm going to times it by the multiplier. Let's just call the multiplier m so it's easy. Or let's call it mul. Let's call it mul for multiplier. So if it's 8 times 1 is 8. If it's 80, it's going to be 8 times 10. Because I'm going to, every iteration, I'm going to multiply it by 10. So right now this is 8. if digit is in let's call it stores. If digit in oh, I already called that other one stores, so let's call it dict or DCT. If digit in DCT for dictionary stores.append digits or DCT digit. So it puts the Roman numeral in here. Then at the very end I have to flip them. So flip the array and append all the elements basically. And then I get my result. So I get the final digit by the multiplier, append it. Okay, if it's not in there, if it's in the dictionary, do it. If it's not in there, so for example, if it's 1,000, so for example, if digit is in there, append it. If the digit is not in there, I want to go, so it's going to be 3,000. So if digit is greater than 1,000, I'm going to divide. I'm going to create a temporary string that I can add to. So if the digit is greater than 1,000, I want to divide it by 1,000. So it'll be digit divided by 1,000. That gives me like 3 or whatever. And then what if I do this? Can you multiply strings? Like if I go 3 times m, so string, let's go to Python Playground. X equals a Okay, perfect. You can multiply strings. So val equals digit. This is my new value. So let's say it's 3,749. If the digit is contained within here, then divided by that amount. So divided by 1,000, so I get 3. And then temp equals val times 3 times dct at 1,000. So it's going to go to 1,000, it's going to reference m, and then times it by 3. That's the way I'm thinking. I can actually just manually force it. This is my way. I don't know any fancy tricks, so the way I'm going to do is kind of go 1 to 10, because it lists out everything. And then for everything else here, I'm just going to go the other route and then just manually get it done that way. So like for example, C is what's called C is 100, right? D is 500, right? But if you had, and if it's, unless it's a 400 or 900, you have to go CCC to get 300, CC to get 200, right? So if it's not these predefined values like you would get here that you don't just add, then you have to manually do it this way. That's the way I'm looking at it. I know it's taking some time, guys, but it's my first time seeing this shit, and I'm just trying to logically think about how to progress without using any cheats. Elif, if the digit is equal to, is greater than 100, so if it's like 200, because whenever you divide by 10, you're just going to get whatever that value is. So this is going to be times the multiplier, right? And then, so right now it's 1, right? And then I have to cut off that letter, that number, and then get the new multiplier, times it by the next multiplier. So what's called, I have to do this. So right now I get the multiplier, right? Well, let's first write out the rest. So let's go, I only have to do 1,000, 110, and if I go anything less than 10, I already have all the numbers predefined over here, so I could just quickly get it done. Right, so 1,000, so less, greater than 100, because if it's equal to 100, I already have it defined here. So that's another good thing for us. So if it's that, so it's going to be the same thing. It's going to be val digits divided by 100. And then you go temp. It's the val times dictionary at 100. So that way you get CC or DD, no, CC or LL. See, that's why I'm only going multiples of 10, because it says here you have to do it for multiples of 10. You could append them consecutively. So this would be M's for 1,000, C's for 100, 10s for L. Where is it? 10s for L, yeah, 10s for X, I for this. I could even extrapolate it to I if I wanted to, right? But it's just simpler to do it the other way. So let's do it, I could stack 10s. So I'm actually still following these rules. Just by going through the logic, you end up following the rules just by the way you go about the question. Like, even without them having to put that here, I naturally just ended up stacking 10s, because look, I'm stacking it here. Stacking here is value times this, and I'm stacking the string, right? So 100 val times dictionary at, so DCT at DCT at 100. And then I'll do one for 10. Elif digits. So it's either going to be predefined, you just add it, so 1,000, 100, or tens. Greater than 10, so if it's like 20, 30, 40 is defined, 50, 60, 70, 80, right? So that's where you want to get it. So right now it's 3,000 before times that. Like 70 would be, oh yeah, and I have to do subtractive form now too. So there's that. I only have to use subtractive form for the hundreds and tens because it only goes up to 4,000 here, according to this. So I'll never see anything higher than 3. So this I could leave as is. So within the if statement, I'll have to do something else here, but let's focus on the logic first. Val equals digits greater than 10, so divide by 10. Temp is val times DCT at 10. Okay, so now I have this. And basically what I want to do is append it to temp. So append it to temp. Whatever I do, I want to append to temp. So or I could just turn it into a string and add it. So I could even get rid of temp and add it to stores. So I could go stores.append DCT digit, stores.append for the thousands, because the thousands is the easier one. There's no subtractive form. So stores.append DCT, well, temp, right? So temp is, well, I could just leave temp as this. So temp is the value, and then value times thing turns into a string. So append temp. Temp is the value turned to a string. Okay, so now the thing is, I append temp, and then once I add this thing here, I want to get rid of the last number. So now I want to go divided by. So it's going to be num divided by 10. Num equals num divided by 10. So that cuts off the digit. And then I want the multiplier to increase. Mult. What's the multiplier? Oh, mul. It's called mul. Equals. So times equals 10. So now the multiplier goes up by 10. So it starts at the last least significant digit, and it works its way up to 10. Then I go stores.append, and then until it hits 1,000, right? And then at that point, then we're done. Because once you floor 10 enough times, you get 0. And then this loop ends. And then when this loop ends, then we can stores.reverse. Or I could just go stores. I could go final equals stores -1. All that does is reverse the stores list, and then I just append the reverse list, so I get thousands, hundreds. Right now it's going 1, 2, 3 up to 1,000. I'm gonna flip it, so I go thousands, add them, and then you get stuff like this. So instead of 58, you get 8, 5. I want to go 5, 8, and then what I do is just join. So I could return the joined item, so I could just go join final, and that joins all the strings, right? So that's done. Now I have to go to logic for subtractive form for the tens and subtractive form for the hundreds. So if right now digit divided by 100, right? If the digit is greater than if the digit is greater than 500, what do you do? What do you do if it's 600? We just go, for example, 700 is okay, so if so digit divided by 100, this is for the thousands, and then if digit is greater than 100, so if it's 700, the val is, I want to get the value, so if val is, so it's gonna be 7, and it's gonna be 7 times whatever. So if it's 7, if the val is greater than 5, because right now it'd be 7 times, or if it was 3, right? For example, if it was 3, and yeah, it was 300, it would be CCC, right? Because you go 100, 100, 100, because it's less than 500. But if it's greater than 500, you have to go diff. So elif, if this is the case, in a normal case, I just go if else within it. That way I don't have to do this. So if the value is greater than 5, and then if the value is less than 5. So if it's equal to 5, it's already defined in the table. So if the value is greater than 5, so I'll just do an if-else statement here. So if, within the if. So this would be the else statement, the normal case, else. Because all I'm doing is following the instructions here. If it says, if you need to append a symbol 4 times, use subtractive form. Right, so now that's basically this. So if it's greater than 5, this val, it's going to be temp equals DCT 500 because it's greater than 5. And then I want to do the difference between 5 minus whatever that difference is. So 5 minus val, or val minus 5. So diff equals val. So if it's 7 minus 5, and then temp plus temp equals temp plus equals. So it's going to be DCT 500 as a string plus what's it called? Diff times diff times, so it's going to be 2 times DCT at 100. That would be, for example, 500 would be D, and then you get the difference, so 7 minus 5 is 2, and then you get DCT at 100, which is C, so CC, DCC. So that would be it, then you gotta append it in these cases, so temp equals I could just go temp equals empty string up here, and I'm just appending strings. So I go temp plus equals to this. You add the value here, then you add the 2 values here, or you add this value here to temp, and then you just append temp. So you go stores.append temp. You do the same thing for the next thing here, so it's the exact same logic. So you go if else, so if val greater than 5, then you do it for the tens. So if val is greater than 5, you have to, what's it called? Not this. Right now this is the else case, so it's gonna be val times whatever. I'm going to call this temp. Temp plus equals. And I'll have to reset temp every time. Stores.append temp equals thing. Well, it does reset on the next loop, so. Yeah, you just get the value times digits, append temp. If you have the digit, just append it directly. Then if you have greater than 5, you want to go temp, create an empty temp here, temp plus equals DCT at 10. And then if it's greater than 5, so if it's like 70, no, it would be 50, because this one's 500. So this would be 50. So if it's 70, you append 50 and then 2 tens. So you'd be doing the same thing. So diff equals val minus 5, and then you go temp plus equals diff times dct at 10. So 5, so you get 50, which is L, and you get 2 times 10, XX, LXX for 70. So once you get that, then you append it, and then you append temp. So if else, and then you go stores dot append temp. And then all you do is get rid of the next number, increase the multiplier by 10, and then you treat the number accordingly. So yeah, you start with 9, basically, goes through the loop. Okay, now you get 4, but that's not actually a 4, it's 40. So you have to times the multiplier by 10 on the next run. So it's going to be 40 and 700, not 70, because the multiplier is now going to be for 100, because it's a 1, now it's 10, now it's at 100, and then it's going to be 1,000. All right, so if you get to that end, because this will remove a digit, so now it's 374, but I want to make sure that last digit is representing the correct number, 40. So I have to times it by whatever the multiplier is. So if, for example, we're on 3,000, right, and I multiply by 10, so now it's at 10,000 as a multiplier, right? Because I got rid of all the numbers here, it won't do another loop, so the multiplier doesn't matter at that point. All the numbers are taken. So once I fill up my array with all the correct numbers, it's going to be backwards, because it's going 9, then 4, then 7, then 3. We wanted 3, 7, 4, 9. So I have to flip my array of strings and join them all. And that'll give me this. So let's try running it. Invalid error, invalid syntax. Invalid syntax. Why? Oh, because there's no comma. Let's try now. Oh, invalid, so there's no comma here. So just use the compiler to fix your code. And there you go. See, the logic is sound. Because what I've done here is basically I just follow the instructions. All it said is value does not start with 4 or 9. Select the symbol for the maximum value subtracted from the input. Append that input to the result. So basically it's saying, that's why I use 5 here. If you look here, within my if conditions, I use 5. Because 5 is your baseline. 5 tells you whether you use add form or subtract form. Subtract form is, for example, let's take letter, I just want to show you guys. Because I know this is a complicated question in terms of if you don't know Roman numerals. Let's take 5, right? That's 5. If I want to go 6, that's going to be this plus 1. So that means essentially I have to go 6 minus 5 to figure out how many of these i's I need to add. 6 minus 5 equals 1. So I need to add 1 I. If I had 7, 7 minus 5 equals 2. So I have to go x, I, and that's what I'm doing here. So basically, let's do a quick recap of the whole thing. Let's submit it first to see. Should be sound because the test all passed. Beats 25.17%, and I knew it was going to pass because all the test cases passed. First, I create a dictionary, right, of all the known values, right? So it tells me anything before the 5 is a known value. So 400 is CD. It's 100 before 500. 900 is known. It's 100 before 1,000, right? All these values are known. I add this to the thing. Then I can, I just add all these from 1 to 10, so it's easy. So I can just look it up in the dictionary. So no matter what I get as my first number, I can just append it right away. Then all I have to do is worry about the 10s, 100s, and 1,000. The thousands are also easy. So good thing is it says if powers of 10, so 100, 1,000, and 1. So 1, 10, 100, and 1,000 are all multiples, or all powers of 10. 10 to the power 0 is 1, right? So the thing is, I look at my constraints. It only goes up to 4,000 or 3,999. So that tells me it's never going to be greater than the 5. So I could always just multiply it by the number of thousands and just add it. There's going to be no subtract form ever, because it'll never go past this number according to constraints. So I could just go str the value. So if it's 3,000, so I divide by 1,000, get 3. So 3 times, and what is that? M is 1,000. So M is 3,000. Right? The hundreds and the tens are where it gets a bit tricky. Right? So if I use this if else statement, if it's less than 5, I do the same thing that I did for the thousands. I just find out the multiple. So let's say it's 30, right? 30 divided by 10 is 3. So then 10 is x. So I go x, that's 30, done, right? And now when I get to 50, or no, 50 is already in here. Now when I get to 60, right? I can't just go x. I can't do that to 6 times, because it says here, you cannot append. If you need to append a symbol 4 times, use the subtractive form. Right, so the subtractive form is the next greatest number, so 60. Okay, that's greater than, what's it called? What I'm going to do next. So I'm just going to go 60 minus 50, because that's the highest number, or that's the subtractive of 5. So 60 minus 50, because that's defined, equals 10, equals x. Right, so it's the exact same thing I'm doing here. 60 minus 50 is 10x, and then 50 on its own is going to be L. So that would be LX. 70, let's do 70 just to show you guys. $70 minus 50 equals 20. 20, if we divide that by 10, equals 2. So that would be x according to this logic here. So for example, if it's 100, so val, so temp is, I go straight to, let's say 70, right? So 50, I add the value for 50, that's L right here, to temp. So now the L is added, then I go, I want to find the number of times I have to multiply by 10, this 10. So I go val, which is, let's say it's 70, right? So 70, it's going to be 7 minus 5 is 2, right? Because this val is digit, and digit over here, if we see, is times the multiplier. So we're going to get 70. 70 divided by 10 is 7. That's my val. So 7 minus 5 is 2. And then 2 times the dictionary value of 10 is x. We go here, xx. So now we get L, x, x, and that is equal to 70. So that's your subtractive form. If you go past 5, you have to go, you have to take the 5 as the base value, add it to your string, and then get the remainder in whatever less values it is. So for example, 500, right? If I had 700, I would have to go D 5, because that's the greatest number, and then these are the 2 remainders. There's 200 remainders. So DCC, what do they do here? 700 DCC, exactly the same thing. So you have to do this for the tens and hundreds. For the thousands, because you'll never have above 5,000 or above 4,000, you'll always just have to multiply the value. So if it's 3, 1, 2, 3, right? So 3 M's, 2 M's, 1 M. That's it. We don't have to do any logic there. So at the end, you get all the values backwards in your strings. So you get the strings for 9, the strings for 40, the strings for 700. So for example, this is in my stores array, IX, right? XL, DCC, MM. Then I want to flip it, so I get mm dcc xlix. Right, so I go stores, use this slicing notation, -1 to reverse the array, and I just join them all. And then I get my outputs. So if you can see here, it passes all the test cases, and it passes the submission. So if you like that question for integer Roman, please give it a thumbs up, subscribe, comment below. Knologist out.